Okay, question 5. So this is my force diagram. Importantly, this force here acts perpendicular to the plank, and it's also at 60 degrees to the vertical. The reason why is because if you extend this vertical line down, you should be happy that you've got a triangle here that's 60, 90, 30. So this angle here is 30. This is a right angle. That makes 120. Which means this angle here must be 60 degrees. Okay, so the working itself, for part A we need to find the magnitude of the force labelled RP. So if we do what should be quite familiar to you by now, you can see that we've got RP cos 60 plus RB equals 3G. And if we do right equals left, we've got RP sine 60 equals a third RB. So this is just now two simultaneous equations, so I'm going to times the bottom one by 3. And now I'm going to sub this into the first one. Finally, I'll factorise the left-hand side. And I'll get my final answer using division. So we've got 3G divided by cos 60 plus 3 times sine 60, which tells us that the reaction at P is 9.5 to two significant figures. And again, because we've used G here, you should have used 9.8 in your calculator, two significant figures is fine. Right, part B then just wants the distance then from A to P, which is a little bit sneaky because you're probably going to take moments from B, and which would give you the distance BP, but the question here is asking for AP. So, taking moments about B, we get the following. So the weight, first of all, we've got a force of 3G, and then the perpendicular distance from B to the line of action of the weight is going to be 1 cos 60. And this one's nice because the force is RP, which we worked out above is 9.5, and then the perpendicular distance is just along the plank, so we'll just call that x for now. Okay, so you can see then that x equals 3G times cos 60 divided by my previous answer for RP, so x is 1.55. So AP is 2 minus x. Which is 0.45 meters or 45 centimeters.